the explanatory power of the quantum mechanical model. Quantum mechanical model is so awesome because it explains what we observe atoms and elements to do. So the chemical properties of elements are largely due to the number of valence electrons that they have. We said that the periodic table is set up in a way that properties of the elements recur periodically, and so elements that fall in the same column have similar properties. The reason that they do is that the valence electron patterns recur periodically as well. So we started off this chapter thinking about why is hydrogen so reactive. You know, the Hindenburg blimp filled with hydrogen went up in flames, and yet helium balloons are really safe and never burn up. And why is that? Quantum mechanics explains that. So let's look at these noble gases. These guys are just really, really unreactive. Some of these don't form any compounds under any circumstances. You just can't even make them interact with other elements. Well, how many valence electrons do these guys have? 8, except for hydrogen. Helium up there. The noble gases are really, really stable because their valence shell is full. They have 8 valence electrons. Their S and P subshells are full. Remember, when the D starts to fill, that's below. So that doesn't ever end up counting as valence electrons. So in chemistry land, I think of the noble gases as being the cool people. These are the ones that all the other elements want to be like. And in terms of being like, you can't change who you are, but you can change what you look like. So these are the popular people. And all of the other elements are trying to become like the noble gases in their electron structure. And so what we see is that the elements that are closest to the noble gases on the periodic table are the most reactive. Let's look at the alkali metals. These guys all have 1 valence electron. If sodium loses 1 electron, how many electrons does it have? Guess we should start with how many electrons does sodium have? It has 11 electrons. This is the number of protons and electrons for an atom. If it loses 1, it has 10. Look at the periodic table. Who has 10 electrons? Neon. So by getting rid of 1 electron, sodium looks like neon. Same number of electrons, same arrangement of electrons. That is an especially stable configuration. And that's why sodium so easily loses 1 electron, because it becomes more stable when it does that. And that's why sodium is so reactive. That's why lithium is reactive. All of these guys are very reactive because by losing 1 electron, they get a noble gas electron configuration. They all form +1 ions for the same reason. The alkaline earth metals, group 2A. These guys all have 2 valence electrons. So to become like a noble gas, they need to lose 2 electrons. And then they form +2 ions. And they do that quite easily, not quite as easily as the alkali metals, because it's a little harder to lose 2 electrons than it is to just lose 1, but they're still quite reactive. Then if we look, yeah, question?
Did reactivity based on how much electrons they're able to lose?
Reactivity is partly due to how close to a noble gas is the element. And so we see that the group 1 elements, because really the periodic table should be a spiral cylinder, right? Because we've got 10 on the right for neon, and then it comes around to sodium. It's a little bit like taking a map of the world, which is a sphere, right? But it's hard to put a sphere in a book. So we cut the map and we flatten it, right? That's how I picture the periodic table. Because really it's just a continuous spiral. And so neon and sodium are really next to each other. It's just that one's on the far east side of what we look at the map and one's on the far west side, but we understand that they connect. So neon is just one step over from sodium. All sodium has to do is lose one electron to become like neon. So the noble gases are this really stable place. It's a very, very good place. And so the closer an atom is, or I should say element, the closer an element is to the noble gases on the periodic table, the more reactive they are in general. So we see that group 2A, the alkaline earth metals, these are less reactive than the alkaline metals because they have to lose 2 electrons. And the halogens are also reactive. But they react by gaining an electron. So here's fluorine. Fluorine has 9 electrons. Well, if it gains 1 electron, it becomes like neon. And that's what they're all trying to do. They're trying to get 8 valence electrons. The shortest way for this to get 8 valence electrons is to gain 1 electron. And so that's why all of these guys form -1 ions, because that gives them that stable configuration. That is cool, isn't it? I think it's very cool. Because chapter 5, we learned nomenclature, right? And I said, well, these are +1 ions because they're in group 1. Quantum mechanics explains why all of those atoms form +1 ions. Why do the halogens form -1 ions? Because by gaining 1 electron, they get a noble gas configuration. It's like, this great coupon deal at the hotel. It's like, well, yeah, but if we could get 1 more, we'd have this group discount. Hey, you, come on over here, join our group, right? That's what people do sometimes. You're at some amusement park, and if you had 10 people, you'd save a bunch of money. So you pull some stranger in with you, right, so that you can get the group discount. And the stranger's like, hey, I'll take a discount, right? I was going in anyway. So that's how I picture the atoms. You can see that there's a lot of strange things going on in my mind, right? That these atoms and elements are doing all kinds of crazy things. Those are the halogens. So this is a table that we saw earlier when we didn't understand why they did this. But now we can understand that the group 7 elements form -1 ions because by gaining 1 electron, they get a noble gas configuration. The group 6 elements all form -2 ions. How many electrons does oxygen need to get 8 valence electrons? 2. It needs to gain 2 electrons. How about nitrogen? It needs 3. And these guys in group 3, they're pretty predictable as well. How many valence electrons does aluminum have? 3. How about gallium? 3. How about, is that indium? I think it's indium. It's 3. It loses the 3 valence electrons, and then it has a noble gas configuration. And these guys, magnesium through barium, they need to lose 2 electrons. Any questions?